For this tutorial, we have the use of CMake with Visual Studio as part of a Windows setup. In this case, we're going a little bit old school with Windows XP. This should all work the same on any newer version of Windows that you have. For us, we have the Spacer project here. That project is on our desktop. If we take a look at that project directory, the starting point here, we have a CMakelist.txt file. And along with a src directory, our source files are actually stored inside the src directory, but let's take a look at the top level CMake list.txt file first. If we take a look at this file, there's a couple things here. The first one here is setting a minimum version of CMake. The second one is actually defining our project. So in this case, we're defining our project named Spacer Project. We then have one final command in our top level CMake list.txt file, which is the add subdirectory, which adds that src directory to our current project, in other words, to the Spacer project. At the same time, CMake will go into that directory and it will look for an additional CMake list.txt file to give it further instruction on how to set up the file, the project. If we open up our source directory now, we can see that secondary CMake list.txt file along with 4 source files that we'll need for our project. If we take a look at this file, we'll see 3 things. The first one is the command to set the C compilation flags for CMake. These flags don't actually work well with Visual Studio, but we're leaving them in here in case we want to generate an additional file later on which uses GCC. The commands though here, the -wall is used to specify to turn on all warnings, and the -g is to turn on the debugging information. The file command here will search the current directory for all .c and .h files, so that will find the 4 source files that we have in our src directory. It will then add all of those source files to this variable sources and use that in the next command, which adds that list of source files to a new executable called Spacer. So the 2 combined sets of CMake files will essentially create a Spacer project that consists of an executable named Spacer, where Spacer needs to be built from all of the .c and .h files within the current directory. So that's essentially the organization that we want for CMake. And we're going to start with our top level directory here, which is our Spacer directory. So I'm going to grab this location here, and we're going to run the CMake command now. So once we start up CMake, the first thing we see here is where is the source code. This doesn't actually want to tell us where are the .c and .h files in our setup. Instead, this should be what is the directory in which case the top level CMake list.txt file is located. For us, that directory is the Spacer directory that we grabbed here, so that's desktop Spacer. That's not the source directory inside Spacer. For the build directory, we want to build this in a separate directory, so we don't want to have the executable files and the CMake files mixed in with our source code. So instead, we're going to come back here, we're going to create a new folder, and we're going to name this build. And then we're going to use that build folder as the directory for our build process. So once we have our project folder here and our build folder set up, we can now do our configure option. If we click configure, we'll see several options here. There's lots of different types of makefiles CMake can create. For us, we're going to use the Visual Studio 10. Even though we actually have a newer version of Visual Studio installed, Visual Studio 10 is sufficient for generating our project here. We can select that and click finish. At this point, CMake is essentially trying to make sure we have a valid Visual Studio project installed. It will test to make sure that it can compile a sample program as well to make sure it can actually build a system using our current setup. Once that process is complete, we can go ahead and do one more step, which is to generate the actual project file. So now that our generating is done, we can close CMake and we can come look inside the build directory here. What we'll find inside the build directory here is the Spacer project debug.sln. This is the main project file that CMake generated, and if we open that, it'll open up Visual Studio for us, and we can take a look at how the Visual Studio environment works. So we see here over on the right hand side in my setup here is the Solution Explorer. If you don't see the Solution Explorer, you want to go to the View options and make sure Solution Explorer is shown. We'll see that there's an all build, a spacer, and the zero check. The all build and the zero check are generated by CMake for us. Spacer is actually the executable name we specified that we're interested in. So if we expand this, we can see the header files and the source files, and we can double click to open our main program over here. And we can now edit our files directly inside Visual Studio. If we'd like to build this project, we can go to Build and say Build Spacer, or we can say Build Solution. This will go ahead and compile our application for us and go ahead and run our application. Well, now we can go ahead and run our application. If we now go to the debug, we typically want to say Start Debugging. But when we start debugging, Visual Studio will choose a specific element of our project to actually run, which currently isn't spacer. If we notice the all build over here is bolded, that means if I say debug, it'll try to debug all build. Instead, we want to debug spacer. So what we can do is we can do a right click on spacer. We can go to the option here, which is set as startup project. So by setting this as the startup project, we can now go to debug. When we state start debugging, it will go ahead and run the spacer project. Now what you likely saw very quickly there is a console appeared very quickly. As soon as it appeared, it disappeared. And that's because it opens in a separate window, the program ran and exited, and we weren't able to observe the output before it closed. So one option to take care of this is we can go to our main program here, and we can add a breakpoint at the closing brace of the main program. What this tells us to do is that when the program runs, once we hit this closing, once we hit the final statement from our main, we'd like the debugger to stop. If I go ahead and if I do the debug start debugging again, now what happens is we can see this arrow over our breakpoint, which tells us the execution has stopped there, and down here we can see the output from our console program. In this case, our console program is now providing us a usage message. It provided this usage message because we didn't specify the command line arguments yet. So this program requires us to specify 3 command line arguments. The first argument is actually the executable name, which is automatically passed to the program, but it's expecting 2 more, one for an input file and one for an output file. So now we need to specify those command line arguments within Visual Studio for when we run the program. So let's go ahead and stop our debugging by clicking on the Stop Debugging option here. We can go back to Spacer. If we right-click on Spacer, we can go to our Properties settings here. When we get to our Properties settings, we can then click on Debugging. Inside Debugging, we'll see an option here, which is Command Line Arguments. So what I can do now is we can type into the command line arguments the location of our input and output file. So we're just going to put in some dummy values here, input file, output file.txt. These aren't actual file locations. It's suggested that you provide the full path for your output file here. And one thing to keep in mind is that what happens with the entries you specify here is every time you find a space here, it separates that into a different argument. So if you want your output file name to actually be output space file, if you leave it like this, you'll end up with 3 arguments, input file.txt, output, and file.txt. If you want the output file with the space to be considered one argument, you'll need to put quotes around that. So any arguments that have quotes within an individual argument, you have to have spaces within the individual arguments need quotes around there. Okay, so if we click OK now, and we go ahead and debug our program, this time we're just going to click the Start Debugging option in the toolbar here. That will run our program. It again stops at the breakpoint. We can switch over here to our project, and now in this case, because we gave it dummy files, we get a different error message which indicates that it can't open the input file, which is okay for us.